Today's video is the second part in this little series where we're discussing the system pressure transmitter. In the previous video, we spoke about where should you install the pressure transmitter. That video is mostly around, considering that perhaps the typical rule of thumb, which is 3/4 down the pipe run, or 2/3 down the pipe run, or just very far down the pipe run, might not be ideal for all buildings. The building that we sort of discussed last time was, there wasn't much chilled water load down the floor. Most of the chilled water load was in the plant room with the big air handling units. So for that particular building, it was better to install the pressure transmitter in the plant room with the chillers. However, we still installed it as far down the plant room as possible at the end of all of the big air handling units. And that was perhaps a better location that represented the load of the building. In today's video, we're going to look at 3 other things to consider. So once you have got an idea of where you want the transmitter to be, a good location for control, here's 3 more things to think about. And the reason why we're going down this road is I have in the past, installed the pressure transmitter in not the best location for control, because that was going to have other issues that would affect the reliability of the control or the stability of the control. So sometimes as design engineers, we have to compromise on control for something that's more practical. So the first point is long cable runs. When you have system pressure transmitters, whether it's chilled water, hot water, secondary condenser water, air handling unit, supply air duct, pressure transmitters, they're usually far away. So if you have a 30-story commercial office, 40, 50 stories, or big hospitals, buildings with big footprints, big shopping centers, those cables are usually very long cables. So you have to think about the cable when the cable runs are very long, because long cables, the 0 to 10 volt DC signal and the 24 volts AC power supply almost definitely will be affected by volt drop for long cables. So you've got to tell your BMS electrical installer that for these particular sensors, we need a different drum of cable. We need to have a cable that has a larger copper cross-sectional area for the cores of the cables. So that 3-core cable, maybe it's going to be a 1 millimeter cross-sectional area. It's a bigger cable. Or you might have a separate cable for the 0 to 10 volts DC and a separate cable for the 24 volts AC power supply. So perhaps your 24 volt AC power supply cable is a 1.5 millimeter cable, live neutral earth. And then your next cable, which is screened, maybe it's a 1 millimeter or 0.75 millimeter copper cross-sectional area for the cable. So with the long cable runs, you can't just install the same cable that you're using everywhere else in the plant rooms where you're running 20, 30 meter cables. You can't use that cable for long cable runs. So the second point is, if you're worried about the cable run, then you should consider not using 0 to 10 volts DC, use 4 to 20 milliamps. My opinion is that a 4 to 20 milliamp signal can run on a longer cable for a longer distance. So in that case, perhaps you would have a 0.5 millimeter or a 0.75 millimeter screen cable, and you're going to try and improve the volt drop issue with 4 to 20 milliamps, and then you have a second cable, 1.5 millimeter, 1 millimeter, whatever it is, for the power supply. So long cable runs, 4 to 20 milliamps is probably a better option. But the point here also is, because you must be thinking to yourself, okay, well, how far can I go? How far can I run my 0 to 10 volt DC cable and get away with it? What's that distance in meters? So when do I switch over to 4 to 20 milliamps? How do I know that? I don't exactly know that, but you could test it. So what you would do is, in your office, you sit down in your office, here's your controller, and you get, maybe get a 4 to 20 milliamp temperature sensor or something in your office, and you wire up a 1 meter cable, and you connect it all up, and the BMS on your controller, it's reading that the temperature in the room, 24.0 degrees Celsius. Then go and pick up a 200, 300, 400, 500 meter drum of cable, plonk it on your desk, put one end in the controller, put one end in the sensor, and then how much did the temperature change by introducing a few hundred meters of cable and volt drop. So are you still reading 24.0 degrees Celsius, or you're reading 24.5 degrees Celsius or 25 degrees Celsius? So that extra cable, how did it affect your signal? And then try a 4 to 20 milliamp transmitter. I did this once when I lived in the UK. I was a BMS design engineer, and I had a big Ministry of Defense project. We had 2 small commercial offices that they were using for design stuff. Then the government had this massive manufacturing facility where they were building stuff, and then with this big, I think it was 8 or 12 bay simulator halls where they had like a cockpit for a helicopter or a ship or a tank or whatever it was, and they used to learn to fly these things or whatever it was. So this is a massive complex with a central chill water system, and I remember sitting there and thinking, I should have a pressure transmitter in each one of these 2 little offices. I should have a pressure transmitter in the main manufacturing hall, and I should have a pressure transmitter in the simulator hall back there. And I remember thinking, how long can that cable be? I didn't know. So we already built the first of the small little offices. I remember going up there with a drummer cable under my hand, under my arm, onto the roof, and a little test. I don't remember how I did it. Maybe there was a duct pressure transmitter, whatever it was. I got the drummer cable, I wired it in, I checked how to affect the pressure, whatever it was. I don't remember what the outcome of that was, but I remember thinking, okay, yeah, I can go that far or not that far, and that's what I did. But I did a test. So for those of you that, you're doing BMS design, you're unsure about something, like test it. Talk to some people, plan in a few weeks to go somewhere and test something. We need to test these things and prove to ourselves how something works rather than just sort of guessing. You might be wrong, but put a little bit of science into it. Now the third point is, do not wire that far away pressure transmitter into the nearest controller and then transfer the pressure across the network. That is the worst thing in the world to do. Do not do that. Whenever I challenge BMS companies on this, I often get the same answer. Yeah, but this is 100 megabits per second Ethernet network. We have a 1 megabits per second backbone between the uplink ports. Don't give me that answer. Yes, the ones and zeros might travel at that speed, but that's not how fast things happen. There's delay in the controllers. You've got the delay of the MSTP on the subnetwork. You've got the control that reads the pressure. It's got to run through its instruction cycle, read all the inputs and outputs, run to the processing code, do its work, into the Ethernet, back through 2 switches up to there, down the MSTP. There's a lot of delay in that. You cannot control a fast-moving process variable like pressure across the network. It doesn't actually work. If you've not coordinated with your installer to run a good cable, and you did the work up front, and you're stuck in this situation where you're stuck, right? The cable doesn't exist between the 15 floors, and you're tempted to cut corners. I would much rather that you didn't control the pressure across the network. I would rather you put the transmitter closer to the plant room, in not the best location, but not have to control the pressure across the network. That's the worst thing you can do. So that's an example of where you're stuck, you've got a problem, and we're going to compromise. We're going to give up, we're going to sacrifice control for reliability. There's no point having a transmitter in an excellent location, but there's a 2 to 3 second delay across the network, and the thing is hunting all day long. That's not a good solution. Also, with new construction jobs, here in Melbourne, most of our A-grade, premium grade buildings have integrated communications networks for all services. That's installed by electrical. So BMS is not installing their BMS network. That network is never ready when power comes onto the building. They've got to install the active switches, they've got to program them all. Those rooms have to be painted, the comms rooms painted, air conditions, doors locked. It's never ready on time. And even when we start witnessing, sometimes that network's not properly running. So you do not want to be reliant on the integrated communications network that somebody else is installing for you to get commissioning going early in the project. So transmitting pressure signals across the network is a big problem. Rather move them closer. Another example of that, once I was a BMS design engineer here in Australia, and I had my air handling units and the supply air ducts. I wanted to put the pressure transmitters 10 floors down. I looked at the drawings and looked at the mechanical design, the architectural, and on those floors we had cupboards for the comms riser, the communications riser. We had cupboards for the electrical riser. Often there's a cupboard for the ductwork riser, but on this particular job we didn't have those doors there. Because the ductwork, once it was installed and insulated, it didn't need to be mechanically maintained. There wasn't a door there. So where do I put the pressure transmitter? I wasn't going to install it in the riser, because the wall would get plastered over and I'd have no access. So that's not a good idea. And I didn't want to install the pressure transmitter in the ceiling, because I've got to get a ladder there. You know, if the floors are tenanted, I've got to have service technicians up a ladder. That's health and safety. It's not a good idea either. So I didn't want to install it there. So I installed the pressure transmitters in the plant room, as far away from the edges as possible, on a straight length of duct before it dropped down the risers to the floors. That's where I installed the pressure transmitters. It was not the best location, and I was waiting for the consultant to challenge me on it. I had my story prepared. I was going to tell them, yes, I went through this, I did a design, there wasn't a good location, I didn't want to have these problems, that's why I put it there. So I installed the transmitters in not the best location for control. They were the best location for accessibility in that case, whereas the chill water one, the network is a reliability sort of issue, stability sort of issue. A lot of this video is about, this is where we want something, but we can't put it there. It's not practical. I think if the next video, I think I've got some notes here about some other things we'll talk about as well. Another thing just quickly to consider is a lot of the reason why we end up being tempted to cut corners and send a pressure signal across the network is because we just didn't coordinate it very well. So basically we build the building, we get up to the chiller plant room, and that's when we tell our installer, oh, by the way, this transmitter needs to go all the way down there. Like if you told the installer 3 months earlier about this, where they designed their containment routes up the building and the amount of cables that were going to go in the trunking up the risers, and they designed that, they would have put a cable in there for you. Like there's the cable, it's installed, it's the right thickness of cable, it's the right quality of cable, there's a power supply cable, a signal cable, whatever it is, it's all designed by the electrical installer. So when you get up to that part of the building where the roof is 3 months later, it's all ready to go. So a lot of the times we're tempted to cut corners because we didn't do the design properly up front, and now we're stuck. This little series is also about design and thinking ahead about this transmitter. Like I'm sure a lot of you will agree that in just these 2 videos, there's probably still one to come if I get to it. There's a lot of things here just about one transmitter. Like imagine if we did a design of the whole chiller plant room, like control panels, the valves, everything. We'd spend 10 or 15 hours talking about it. All right, so let's wrap this up. What is your call to action? This is not Netflix. It's not supposed to be an enjoyable movie. It's probably not that enjoyable. It's probably a bit dry. But your call to action is, what are you going to do about this? So for those of you that learned something, what are you going to do about it? I'll give you an idea. Most BMS companies, or at least when I worked for BMS companies, we never had this. We didn't have our own company's little mini installation guideline or installation spec that we would give to our electrical installers. Remember that your subcontractor, the electrical installer, they probably do not read the mechanical specification. They don't read the electrical quality requirements in there. I don't think they read that. So what happens with us is, BMS companies, it's almost like we allow the electrical, our subcontractor, to decide what the quality is of our install. So in this little 1, 2, 3, or 4, or 5 page little installation cheat sheet that you give to your subby, it says there, all system pressure transmitters for air handling units, chill water, hot water, etc., should be installed in this quality cable, like the Belden reference. Put there the cable reference in there, exactly what it is. It's a screen cable, blah, blah, blah. And, instrumentation cable for plant rooms, it's this quality cable. What color should the cable be? Maybe your BACnet MSTP RS485, 3-core screen cables, maybe they are gray cables. Maybe the cables that you use for instrumentation, valves and sensors, maybe they're black cables. Containment rules. You should develop that, because it's probably not ideal that our installer, the quality of your installation is just dependent on somebody else. In the previous video, I was talking about, I've seen a few jobs where we got Cat5 cable, I think it was the previous video, Cat5 cable used for instrumentation rather than proper screen cables. And I asked the question, if anybody knows the answer, why do we use Cat5 cables for control? And somebody, let me just check that. Philippe says, Cat5 cable is cheaper, Bryce. I said, thanks, mate. Philippe, I've met him before. He lives in Melbourne. I think he's a French guy. So yeah, Cat5 cables cost less than screen cables. Thanks for clarifying that, Philippe. That's why they sort of sneak in there. But why do we allow our installation subcontractor to decide that they're going to install Cat5 cables in certain places and not the cable that we need? We shouldn't leave that up to them. So a lot of these things, we could trap some of these problems by having a little electrical installation sort of cheat sheet. So go talk to your manager next week. Say, hey manager, let's put together a little working group, 3 or 4 of us. I'd like to be involved, not me, you. And we'll spend 2 or 3 months. We'll spend a couple of hours a week. We'll workshop it. We'll put together a little electrical installation guideline for BMS, control panels, floor standing, wall standing. Half the jobs I go to, I open the control panel, the cables are not numbered wide into controllers. Half the jobs are not numbered. If I take the cap off the actuator of the valve, those cables are never numbered. There's no point me defecting that. It's too late in the game to throw hand grenades like that over the table. This is pointless. That's not going to be fixed. But for your company, for the brand of your company and the quality that your company provides, to your customers, the mechanical contractors and building owners, what do you want it to be? Do you want to put cable numbering on the controllers, but not the sensors? What is it? How's it going to be? So work through that, and we could very easily improve the quality of installation. We shouldn't leave it up to our installers to decide that. So like and subscribe. I think there's one more part to go. Like, apologies guys, there's been quite a big break in time between this first part and the second part. I've been very busy. Last year we were in lockdown a lot in Melbourne, so I could record almost every week. We're sort of restrictions have been easier in Melbourne, so my wife, she wants me to go places on weekends. Last weekend I had to go away somewhere. Next weekend I've got to go away somewhere, so it's becoming more difficult to create the videos. Have a good week, and I will see you in a few weeks again.